Okay, 8.7 Power Series. In this section we introduce the idea of a power series, how to test for convergence, and ways of thinking about a power series that eventually are going to lead to things like Taylor polynomials and Taylor series. Okay, so a power series, what exactly is that? Well, you probably already know that we can represent a power series kind of like this. We have a sum n is equal to 0 to infinity, and we have this equals to c0 plus c1 x plus c2 x squared plus c3 x cubed dot 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 off to infinity. And that's a power series, and we see it's powers of x, okay, and it looks a lot like a polynomial. In fact, if we were to just cut it off as a kind of a partial sum right there, that would just be a polynomial. It goes on forever, but we'll find the properties of power series in some ways act a lot like polynomials in terms of multiplying and dividing, subtracting, and adding. Okay, so now let's just take a simple case where all these c's are equal to 1. Okay, so then this simply becomes 1 plus x squared plus x cubed, something like that. Well, this looks familiar. We know this is a geometric series, and we know that if the absolute value of x is less than 1, we can calculate this sum as 1 over 1 minus x, right? And in fact, we've done that quite a bit. When we were testing convergence, once we found convergence, then we could plug in here and we'd come up with a number. So if x is equal to 1/2, 1 over 1 minus 1/2 is equal to 2. And this infinite series then sums to 2. We can also look at it from the point of view. Now, this will sound a little weird, but we can look at it from the point of view. If for some reason this quantity was difficult to calculate, it actually isn't difficult to calculate, but if it were difficult to calculate, we could use this quantity to tell what this was. In other words, we have an infinite series, and it is going to be equal to this. Therefore, if we can't calculate this, maybe we can calculate this sum. Maybe not of an infinite series, maybe it's only going to be of a partial series, but that would give an estimate of what this is. So, for the geometric series, we normally think of, we can easily calculate this, and therefore we know what this is. But it's an equal sign, it works both ways. This can be used to calculate this as well. Okay? Now, this isn't the only kind of power series. We could say, well, what if we had a situation where we're going to change this just a little bit. Let's reintroduce our c's. And now instead of saying x, we're going to make x minus, in the book they put an a in, which is fine, but I'm just going to actually put a real number in to make it look x minus 2 plus c2 x minus 2 squared plus c3 x minus 2 cubed dot 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 to infinity. This still is a power series. The difference would be that we would say this was centered at x equals 0, and this is going to be centered at x equals 2. Now that's, centered at, what are we getting at here? Well, let's just for a second imagine all these c's are 1s also. So this, it just looks like a geometric series where we've got x minus 2 in it. What does this look like? Well, first off, let me plot out this first one up here. And geometric series, we're really, because of convergence, we're interested in -1 to 1. At 0, we get 1 over 1 minus 0, which is 1. So we know that the function is 1. At 1, we get 1 over 1 minus 1. Well, that's infinity, so we've got a vertical asymptote here. So, you know, we got something kind of going up like that. And at minus 1, we would get 1 over 1 minus a minus 1, which is 1/2. So we get something that kind of looks like that. Okay, so what happens then when we take this x minus 2? Well, you already know this. Remember how we used to move parabolas around, you know? X minus 2 is simply going to move this whole curve over. Let me get another colored pen here real quick. This is just going to move this over. Here's 1, 2. Now this whole curve is going to move over, because now when we plug in 2 here, we get 2 minus 2, which is 0. So this power function is going to be 1 here, and then it has a vertical asymptote at 3. So we've just shifted our curve over, and it comes down to 1/2 here. And you can look at that and convince yourself, but all we've done is just shifted the curve one way or the other. So when we talk about centered at x is equal to 2, we're talking about shifting the curve back and forth. And there are various ramifications of that, but that's kind of what we're talking about when we're talking about things centered or not centered at 0. Okay, let's try example 2 in the book. And what they do is they show you a series that looks like this. 1 minus 1/2 x minus 2 plus 1/4 x minus 2 squared plus ... something like that. Let me change my pen color here. That's kind of irritating. And they say, well, what are we going to do with this series? Well, what we'd like to do is put it into a geometric series so that the answer is going to be on this kind of order, or maybe I should say something more like 1 over 1 minus r. We'd like it to look like this. Is there any way we can rework this? Well, we got this x minus 2, which means it's centered at 2. That really isn't a problem to us. If that was all that was going on, all we'd have to do is substitute in, and we get 1 minus now x minus 2, and we could proceed from there. But we've got the c's now, 1 minus 1/2 plus 1/4. This next one here would be 1 minus 1/8, like that, etc. And if we thought about this for a while, we could probably figure out that what this is really looking like is something on the order of, we've got x minus 2 divided by 2 to the nth power, and we need a minus sign in here. Now let's see if that will work for us. So we try to substitute in n is equal to 1. We get x minus 2 divided by 2, a minus, yeah. And then we make n is equal to 2. We get x minus 2 squared. The negative sign goes away. The bottom it becomes 1. Yes, that works. And this is our term. So now we can say that instead of 1 over 1 minus r, well, that's sort of equivalent to our form here is going to be 1 over 1 minus a minus x minus 2 over 2, like that.